Hello, thanks for joining us today. Joined here are actually Jeff Morris, our Vice President of Product and Solutions Marketing, is leading us today in a great discussion how to choose a flexible database designed for evolving applications. And a theme throughout, we are going to be talking about some financial services use cases in this, and we've presented it as such. But keep in mind that these are not only use cases used in financial services, these are very adaptable use cases that can be used in many different industries. And Jeff is going to talk a little bit about that as well. So in the meantime, hang back, keep your questions coming in the Q&A area, chat with your fellow participants, and I turn it over now to Jeff.
Oh, thanks so much, Suzanne, and welcome everybody. Let's talk about how to choose a flexible database designed for adaptive applications. And I'm going to use, as Suzanne just said, financial services use cases, but this applies to arguably any kind of user-centric application that requires high performance, a lot of flexibility in terms of the features that you're able to offer your application through a database. It offers mobility, and when you're running it, it doesn't break the bank, right? Fundamentally, those are the key points that we want to end up making out of our conversation today. So I want to start this out with a day in the life kind of slide to let everyone know how frequently they are indeed interacting with a Couchbase powered application, whether it's the driver, the Frito-Lay driver who's delivering your Tostitos to your supermarket, or when you're handling PayPal interactions, or when you're scrolling your LinkedIn feed, that's all cached in Couchbase. If you go into a Louis Vuitton and they start to show you their entire catalog of inventory on a tablet, that's actually Couchbase. And if you're going on a cruise on Princess Cruise Line, or you're playing EA Sports and looking at your leaderboard, those are example Couchbase-oriented applications that are pretty familiar with people every single day. So, and also there's the receiving fraud warning example. So let's dig a little bit into that. That's FICO's fraud detection monitoring system. It's an application called Falcon Credit Monitoring, and it's powering or monitoring over 3 billion credit card accounts. It's doing this all in real time. It's caching your account profile within Couchbase, and it's providing less than millisecond response times for the application, so it can figure out if a particular transaction is valid or not. And the way they characterize it is 2/3 of the credit cards in your pocket are likely being monitored by Falcon and this particular service. So these are sort of examples, as Suzanne said, of what the market expects out of their user-centric applications right now. The goal is to deliver these really phenomenal user experiences that are indeed adaptive. They're highly personalized. They're super responsive. They happen in real time. They give you immediate information, whether it's matching your profile to a catalog of inventory of stuff, or providing some other kinds of capabilities. It's very, very informative for that user. Now it needs to operate anywhere. And that means in many cases, it needs to be mobile, because people have feet, they move around. And of course, mobility, your mobile device is the first place you look for arguably any information right now. And it's got to be dependable, right? Even with transactionality in many cases. For the people building these kind of applications, what customers tell us is they're looking to expedite and become more efficient in what they're building and how they're building it. So they want to accelerate development activities with generative AI capabilities. They want to tap into everything, their existing knowledge bank, everything that they know, like their SQL programming skills, for example. They want to support microservices-based best practices. They want to avoid data sprawl. So start recognizing that the ability to use a multi-purpose data store rather than the purpose-built ideas that we've been taught for the last decade. Using a multi-purpose system may indeed be better from the standpoint of reducing cost and reducing data sprawl, reducing complexity, and maybe improving trustability for when you might build an AI-enabled application in the future. And then when you're deploying these systems, of course, it's got to support the edge, as I just mentioned, but it's also got to support global scale. So that means a distributed application that's running on different continents and different locations. And you want very flexible management capabilities. And of course, you can't break the bank with these kind of systems. So when I break down these kinds of user-centric applications, there's a couple of fundamental objects that we see in almost all of them. There's those account profiles, right? And why, of course, you're trying to create a personalized experience with those account profiles and match them to that big catalog of stuff, whether it's airline tickets, financial transactions, products in your store, videos that you watch, or media that you're streaming. All of those would be the stuff that you're interested in, and all of those preferences are things that the account profile is going to end up containing. You're going to have, as I mentioned, devices operating, your interfaces for interaction with that catalog. It's going to happen in time, place, and space, right? So there's location information that you're going to want to know about and be aware of. In many cases, that's to reduce the latency of delivering perhaps a large video file or delivering that killer application experience when there might be low network connectivity. So location is a very important thing to consider. There's whatever the functionality of the application does, the interactions, and of course, there's where it's operating, whether it's operating using legacy data or operating in whatever infrastructures you're deploying your systems in. That kind of information is very important for consideration of how you're going to build these perhaps adaptive applications that you're looking to create. But there's also ways in which to look at this from the standpoint of a developer. And what are the kinds of things that you're looking for when you're considering each one of these types of application objects, right? For your account profile, you really want adaptability there. You want the profile to be flexible so that you can build personalization into it and match up to that complex catalog and take context into account for what's happening with that profile at any given minute. As I mentioned, that location information on a macro scale is related to distributed workloads. Can you process globally the same way that content delivery delivery networks were first rolled out back in the early 2000s, or even the way Netflix behaves now, where they deploy the media that you're watching as close as possible to you to reduce that network latency of where that media is going to end up showing up. There's, of course, mobility. That's the device information. You're going to tackle problems around developer productivity, as I mentioned before, how you make them, give them the capabilities to build very feature-rich applications, but also allow them to do so in a rapid manner so that they can evolve and move forward very, very quickly to deliver and continuously deliver those great experiences. Application performance is a big issue with regard to the interactions that you're dealing with. Can you handle a high degree of user capacity, for example, and ensure that there's no latency wherever that interaction is taking place? And finally, can you manage and maintain your high cost of operations? A large application could take up an immense amount of resource, but you need your application, especially if it's user-centric, you deliver on your ROI commitments and promises, and ultimately helping you shrink your cloud footprint in many cases so that the application can perform, but again, not break the bank. So let's put a financial services oriented lens on this particular set of requirements. We're seeing that in the financial services space, more than 72% of customers expect their digital banking to happen in real time. I put money in, I put a check in the ATM, I want it to show up in my account immediately. So, and that's going to end up facilitating low switching barriers, and zero tolerance for lag is one of those core user requirements that you're going to be very familiar with. Security and data privacy are ultimate. They're absolutely number one considerations. The financial services customers I'm talking to, in many cases, are operating in their own data centers because of privacy concerns, and some are only beginning to dip their toe in the cloud. So security with speed is a non-trivial exercise, of course. And of course, millennials, 97% of them, and 89% of consumers rely on mobility and mobile banking apps. So this is only going to, that number is actually only going to go up in terms of the feature functionality that you need to be delivering. So there's a couple of other observations that we make is, the 2x, the Moore's law of data is really, global data has been doubling at a rate of like every 24 to 36 months. So, just like Moore's law for hardware, very similar explosion and rapidity of growth here. But we also tend to think of not only is that data volume growing, but the complexity is growing. And that's actually an issue that AI-oriented applications are going to need to face. AI doesn't like complexity. That's what introduces the opportunity for your Gen AI interactions to hallucinate if you're worried about that. So really one of the goals that I think organizations are going to be seeking is trustworthiness in the data, and cleanliness in the data, and single sourcing the data so that you're not gathering it from multiple disparate sources in order to eliminate the opportunity for hallucination. One of my analyst friends, Carl Olofsson, reminded me, he said, remember that generative AI activities are very imprecise. The answers are very imprecise. But yet you as a database vendor can help improve the precision of what goes into the AI in order to bridge that gap and make the results coming out of an AI interaction much more precise as well. Because of course, databases are transactional, are kind of binary. It's either correct or not, or incorrect in terms of values that are being stored in the data. So that kind of blending, I thought, was a really good observation. So the goals that we're seeing for a financial services organization to help meet the speed, security requirements of users is very similar to what I just laid out earlier. Meet the real-time usability expectations, deliver in a mobile-first world, provide architectural flexibility, and anticipate that you're going to need to change the application. It's not static. It won't be static. You're always going to want to be improving the data that you're using to create that personalized experience. Maybe you need to add attributes to your user profile such that to improve what you happen to know about the preferences of a particular user or consumer. Jeff likes blue, for example. So, offer him things that the credit card that is blue itself. You want to make sure it scales. You want to make sure that you understand what the interactions that are going on inside those user communities. So expand your customer 360 customer view so that you can have fully represented personalization kinds of capabilities in there. And the challenges you're going to end up facing, of course, is high availability, making sure that it runs wherever you expect it to, scaling all of that user load without introducing new latencies or without introducing slowing down the backend systems. Data complexity is always going to be an issue, as I just mentioned earlier. Security and compliance is going to be a core issue, as we mentioned. And again, doing so in a mobile-first kind of world. So now let me transition a little bit into kind of the problems that customers come to Couchbase for. And as I mentioned, those problems of the applications that we went through earlier are going to end up matching up to reasons why customers trust Couchbase for these kinds of applications. Number one is performance, right? We're built with a memory-first, caching-oriented architecture. Everything happens in memory immediately. You'll recall that the origin story of Couchbase as a database was the combination of the development team who was working on memcached from Membase and CouchDB from Couch1 merged together to create the design of Couchbase itself. So it's cousins to Memcached and distant cousins from CouchDB now. But that origin story of let's make it really fast and in memory, let's make it really flexible with a document structure as our primary data structures with that JSON flexibility are the two things that Couchbase is built upon. And then we added in a number of other really interesting services and capabilities, such as mobility. We have Couchbase Lite, an embeddable database. We have great synchronization capabilities we'll talk about in a minute. And because it's very high performance, it's very, very scalable, and you can actually scale each service of Couchbase independent of one another. That's what helps drive down our operating costs. So if your cloud bill is kind of scaring you, then Couchbase is a great alternative here. So the kinds of use cases that we're addressing is, the front end to back end kinds of use cases of offloading legacy systems and helping preserve their life by perhaps introducing Couchbase as a cache in front of it. That's typically the first use case that we end up adopting. Supporting JSON-based personalization capabilities, supporting session and token management inside of your application activities, or supporting transactions. And yes, indeed, JSON documents can support ACID transactions, multi-document distributed ACID transactions in Couchbase's parlance. And in fact, we've got patents on that. You like the flexibility of a document store for the same reason that you create a personalization profile for users. You're probably changing and adding and modifying your catalog of stuff, your product catalog at the same time. So supporting dynamic pricing policies, supporting different selling techniques or sales and whatnot for or bundling or areas where product catalog kinds of capabilities JSON is great for, as well as Customer 360 and those profiles that I mentioned earlier. On the, we're developing a lot of data here, handling a lot of data. So support for real-time analytics, support for risk analysis, fraud detection are also areas where we see organizations building with Couchbase, and mobility, field service, edge computing kinds of use cases all over the place. Those are only growing in importance as we mentioned. The business benefits you might see are things like better customer satisfaction, right? Faster time to market, drive loyalty, right? Improve cost savings, lower your TCO, and if you're building a shopping cart kinds of application, convert more customers, right? Reduce cart abandonment kind of capabilities. For financial services, we see ourselves playing in a number of different areas, right? Trading desk, streamlining all the different data sets and to empower traders or to empower other development teams to use today's data to make whatever other capabilities that your constituencies are asking for. E-payments, like I said, that eBay use case, we have a number of e-payment oriented customers that are building with Couchbase. Fraud detection, mobile wallet, and of course, Customer 360, aggregating and using all that information to figure out what you ought to be working on next. All very, very common kinds of use cases for Couchbase here. So let's talk a little bit about one of those payment systems. PayPal is using us for both user activity and real-time analytics. They're using both Couchbase Server and Couchbase Mobile to understand what the user interactions are going on in their mobile wallet and in their operational dashboard. They're gathering clickstream information. They're gathering real-time data all over the place and managing over 1 billion documents and terabytes of data. The whole system, the benefit that they're enjoying is the views that they're generating for their analytic business users are happening in a matter of seconds, and they're able to process millions of updates to the environment, millions of updates a minute. So very, very high speed, lots of interaction, lots of play here in the PayPal area. Equifax, another credit monitoring system, making sure that there are nearly 1 billion users and 91 million businesses are their credit monitoring system is nice and stable. It reports trustworthy information and is available all the time whenever anyone is requesting that kind of information. So it's using our caching capability. They built out a user profile store here, and their data itself has grown into the petabytes, and it's constantly changing and evolving. So they moved from a relational system to a NoSQL system in order to scale that environment significantly more effectively, and then be able to provide millisecond response times while handling, like I said, 1.5 billion records that are changing all the time. So very, very large volumes of profile information for credit monitoring. Other customers who are in play here using Couchbase, in many forms: fraud detection, provisioning user information, provisioning data for different parts of the organization. Using it for providing real-time cloud-based banking capabilities. As a matter of fact, this global financial service provider, one of that has moved more than 10 of their applications from their on-premises deployments into Couchbase Capella, our database as a service. And they were able to do that within the course of about 6 months, is moved all 10 of those. They continue to grow their footprint in Couchbase and push the footprint of Capella in directions that we like to see it going. So their requirements, 5 nines worth of uptime. That means 5 minutes a year worth of downtime. Make it very, very easy to manage. Make it easy to upgrade, and push the responsibility for upgrading the database systems to ourselves, to Couchbase as the manager of the environment. They are enjoying reduction in TCO. Their DevOps headcount can work on other things, and they're still meeting the specific security requirements that they were anticipating and requiring out of us. So Capella is the data platform of choice there. They're transitioning themselves from being a money transfer or a kind of service to really becoming a full service internet bank, SoFi style, as you could think of. So as I mentioned, those required capabilities: sub-millisecond response, security, right, offline and edge capabilities, high availability, flexibility from JSON are reasons why you would end up building these kinds of capabilities. I've got another fraud detection example. Fraud monitoring through Revolut. Their Sherlock system is a machine learning based fraud prevention system. It's won many financial services awards in their space in Europe. So their requirements were, this is a mission critical application, of course. It's got to be available. It's got to be high performance. They picked Couchbase because of that speed, agility, scale, and their ability to maintain being flexible to change, the data needs of both users and merchants that they're helping. They saw, a 75% improvement in performance, in tracking, in fraud identification over their industry standards. They saved over $3 million, and they're catching 96% or more of fraudulent transactions right now. So let's look at Capella a little bit. I want to give you an overview of the kinds of technology that Couchbase Capella offers, and Couchbase in general offers. Capella is our database as a service. It's fully managed. It's enterprise caliber. It supports development flexibility in terms of what you're trying to build, when you can build it, taking advantage of your existing skill sets. Like if you know SQL, you're going to be very comfortable using SQL++ inside of Capella. We've got an AI, Gen AI assisted conversational coding capability we call Capella IQ. I'll show you a picture of that in a minute. But it'll automatically scale up and down. In fact, it has an on-off feature where for your developers, you can turn your database and your environment off for the evening or for the weekend. Save, it basically really truly map to you're only paying for Capella when you're using Capella. So really convenient capability there. We support a single pane of management glass, so you can see every single Couchbase Capella cluster that you might own, and in fact, every Couchbase cluster can be observed through this through the Capella interface. We support mobile and IoT app synchronization and embed, with the embeddable Couchbase Lite database, and supports enterprise security requirements. What really makes Couchbase special is kind of these different tiers of functionality that we offer. So from the standpoint of data access services, right, the kinds of things that we do in terms of how we behave as a NoSQL system or a multi-purpose NoSQL system, we support JSON documents as our primary interchange format. It's the developer's favorite. And in fact, it's becoming Gen AI's favorite data format. As you'll recall, about a month ago, ChatGPT, OpenAI announced that they are supporting JSON as an exchange format for conversations with ChatGPT. We support key value access. If you need direct, programmatic, instantaneous access to particular data values, that's available to you. We support SQL as a query language. So all of your skills that you happen to have developed over the course of time using relational systems like MySQL, Postgres, Oracle, all of that knowledge that you have works inside a JSON environment. SQL++, our query language, is SQL for JSON. You can join documents. You can you join together different collections. If you want to have a normalized kind of schema-like structure for your documents, that's available to you. You don't need it all the time necessarily, so that convenience and flexibility is also still available to you. But we also have an engine for full-text search because, of course, users can't type and they really like that Google search box experience. We have a brand new columnar storage service called Couchbase Columnar, supporting real-time analytics. I'll talk about that in a moment. We support time series data in JSON. In fact, we can support graph data inside of JSON. We support eventing and streaming as a particular service. So if you want to be capturing document change events, you can do that and then stream it to some other application, perhaps via Kafka. And then, of course, we offer the embedded mobile database. So all of those data access patterns are supported inside of Couchbase, allowing you to ultimately reduce the amount of other purpose-built databases you might be requiring in your application. So compare and contrast that kind of delivery model. But all of this inside of Couchbase is built upon an awesome performance foundation. I've already mentioned everything is memory first. Everything is cached and happens in memory, whether that's reads and writes to the database, whether that's replication to other nodes in the database or other locations where your database shards might be. All that replication happens immediately, and then also instigates the cross data center replication functionality as well. We have a high performance, high data density storage engine called Magma, which is our underlying key value database that if you want programmatic access to that information, it's available to you. We support ACID transactions, as I mentioned before, just like your favorite SQL database does. We have this great notion of a cluster map. And this is when you define a database inside of Couchbase, how the data itself is going to be partitioned and stored for high availability. And distributability and scale, of course. So the cluster map is the mechanism that we use to inform your application where your data actually lives. So the application always knows where the data is. It doesn't have to go through an intermediary to find out where the data is, like some other competitive products. Nor does it need to operate as a primary and leader-follower kind of architecture, as many products are. Any node in Couchbase can take a write, and any node in Couchbase can offer a read because it knows where to look for the data all the time. The application tells it. So the cluster map facilitates that. It's one of the coolest capabilities I've ever seen in a database. We now offer columnar storage for high scale, high speed real-time analytics that consider that like a data mart that's adjacent right next to all of your operational application information. So when you need to feed your application immediate information that's from a high scale aggregate, perhaps a measure like what's the current inventory right now, and can I make a big change to it? Do I have enough to fulfill a massive order? You can run that kind of calculation in Columnar and receive that in real time and immediately write it back to the application itself. We're actually, I'll get to this in a minute, but that notion of being able to take an analytic measure and do something about it immediately without human interaction is a rarity in the database space. In fact, go talk to anyone from any of the analytics side, the Snowflakes, the Redshifts, and whatnot, and they're all talking about an idea called reverse ETL, right? But this is just connecting closing that final loop between I have an analytic insight, I need to do something with it in my applications. You can do that in Couchbase in real time with Columnar real-time analytics. As I mentioned, we have active clustering. So, like I said, any node can take a read or give can take a write or give a read. That's all facilitated by that cluster map. We also have workload tuning. Every one of those upper services I just mentioned there, the query service, the index service, the key value service, the search service, etc., can scale independently within a cluster node. So if you have a heavy query load, give it more resource. If you have really heavy indexing loads, give it more resource. And you can do that independently of all the services of Couchbase. I've never seen anything like that before either. And then finally, geographic replication for cross data center replication, for cluster to cluster replicating, as well as synchronization from Capella app services or the sync gateway for self-managed deployments. And even mobile databases of Couchbase Lite can synchronize amongst each other if they happen to be on the same local area network, but maybe the internet's out, and the systems can always still work. We call that peer-to-peer syncing. Again, unique to Couchbase. So when I say we're fast, we test ourselves against every other database. So meeting that particular performance demand, we need to prove ourselves out. So we've hired third parties that exercise Couchbase against a number of other competitive solutions. And not every time, but most of the time, Couchbase comes out very strong. And if it doesn't, there's usually a particular reason why Couchbase didn't come out as competitive. Like in the DynamoDB space, when you're using Dynamo, you typically set a financial limit as to how much resource you want to be consuming in the Dynamo environment, and then when you exceed that, it behaves in unpredictable ways. But all of these are ultimately proof points of, Couchbase is typically very, very fast and highly competitive with every other product on the market, even if it's another in-memory oriented product. And you'll even look at the Redis work that we did here. Remember that Redis is a cache. Oftentimes it has to work with a second or third database like Mongo or like Elasticsearch to offer the same kind of functionality that Couchbase does. So as I mentioned, JSON is awesome for that flexibility, the ability for the developer to control the data structures they're using, not the DBA, not having to ask for schema changes from a relational database. The developer's in control. If you want to add a new attribute, you just do it. If it only goes in one document, that's fine. It doesn't require a massive schema re-rollout. You can just make the change and move forward. So it's highly, highly flexible in terms of what you can do with your data. And again, the developer remains in control of that. And it's accessible from a number of different data access patterns, whether it's that direct key value I mentioned, query it via SQL, query it via search capabilities, query it as time series data. All of these are available to you. I keep talking about SQL++, SQL for JSON. What is it? What makes it cool? It's basically the exact same syntax and function of regular SQL 92 from relational databases, except applied to JSON. So where you're dealing with a JSON document, that might be a row in a table in traditional SQL parlance. But it supports distributed ACID transactions. You can have user-defined functions. It's the same language that we use for the large-scale analytic capabilities of Couchbase columnar. And so as you look at an example of relational SQL and SQL++ in my two boxes in the middle here, hopefully you'll notice that it's identical, that each of these queries. Whereby, if you look at an imperative language, it's much more complicated in terms of what you have to write to get the database to do what you want it to. And now Capella has added Capella IQ. This is our conversational coding assistant. Use natural language, ask it a question, help make me a query that does the following, help write a Python program to tell me what to tell me how to execute this query. In this case, I'm saying what's the busiest airline flying out of San Jose Airport, and it goes and writes that particular query and will tell me the answer. So very, very convenient capability here called IQ. It'll help you build indexes. It'll help you build test cases. It'll help you build sample data. All of these directly just typing in your inquiry. It uses uses ChatGPT 4 Turbo right now, but will support your favorite LLM in the future as it evolves. So if you want to code with Claude, fine, or Llama or Bard or Gemini, all of these new LLMs, that's going to be available to you as well. And I mentioned Capella Columnar. We just announced this back at reInvent timing a couple of weeks ago. And so this is a brand new service inside of Couchbase Capella that separates compute from storage, right? So we've got our independent compute engine doing calculations against a columnar-oriented storage format that's stored in Object Store in S3, and it will scale independently as the other Capella services do, but it's also able to ingest data via Kafka from other third-party systems, or ingest and write data to a variety of different data formats, JSON, CSV, Parquet even, supporting object store connections. And it's operated by the same Capella control panel, and it supports development, analytic development using either Tableau or Power BI. It's got JDBC and ODBC drivers associated with it. And this is what's going to allow you to build your real-time adaptive applications here. And these adaptive applications, they're going to end up being operational, transactional, analytical, AI-enabled. All of these are what we expect the next generation of applications to become. So our use cases for that adaptive analytic capability, we'll call it hyper-personalization, with significantly more context associated with what's going on. It will, it could provide information like, where are you? It could, help support real-time decisions that might change the entire characteristic of the application. For example, the example that we use right now is, remember the baseball playoffs, the National League Championship Series, when the Dodgers were playing the Diamondbacks, and the seventh game was the deciding game. We had Clayton Kershaw on the mound for the Dodgers. Well, unfortunately, Kershaw gave up 11 runs in the first inning. Now, our customer Domino's Pizza, when they originally bought the Couchbase for their analytic capabilities, they were able to reduce their turnaround time from 3 weeks to looking at all of their point of sale data, churning their analytics, and coming up with the next set of offers that they want to make to their market. That turnaround time was 3 weeks. Well, that was too long. What they really want, what they'll be able to do with Capella Columnar, is real-time pivots. So what they would have liked to have had is when Kershaw had that meltdown, is instead of focusing on the Los Angeles market for all their offers, pivot immediately to the Phoenix market or the Arizona market. Also probably pivot to the San Francisco market, because we don't like the Dodgers either. And then do the large-scale analytics of, do I have enough dough? Do I have enough drivers? Do I have enough capability in those markets at this moment, from the second inning to the ninth inning, to celebrate the D-backs going to the World Series to play the Rangers? That kind of pivot will be possible with Capella Columnar and these adaptive analytic kinds of capabilities. But you'll also be able to embed user-facing analytics inside your applications. You'll also be able to evaluate what's going on in your applications and gain deeper insights and even perform that kind of write back I was talking about a moment ago. So, and we're also anticipating that these kinds of applications are going to be AI powered or AI enabled in some form. But when we looked at what is it really going to take to create or allow our customers to create AI enabled applications, we realized a number of different characteristics that are going to be required or be in play in order to successfully do this. So of course, these applications, they're going to be transformative. They will be really, really killer. The scope of this, we believe, is going to be about the same size as the original Y2K problem. It just doesn't have that New Year's Eve deadline associated with it. But you're going to look at every single application you have, or every application that you are developing or thinking about developing. You're going to look at it and evaluate whether there's AI capabilities that you could put in that application. But here's the requirements that you're going to need to satisfy also. Number one, you're going to realize your AI prompts, that requires a lot of different kinds of data, right? Really diverse data. Well, guess what? JSON is a great data format for supplying diverse types of data, like numerics or large-scale analytic metrics, along with text, along with location information, along with metadata about the data. When was last accessed, right? What catalog is this stored in? That kind of information can be passed through JSON very, very easily, right? And even aggregated from multiple sources. But you're also going to realize when I say that, you're going to go, oh, but wait, if I'm feeding an LLM through my application and I'm feeding it from different data sources, specific, individual data systems, how am I going to tell which data variable I fed it is actually the thing that caused it to hallucinate? You're not going to be able to do that. That's what I meant earlier when I said that complexity is really the exponential enemy of AI, is that data complexity. You want data that's very, very trustworthy. You want it to be singularly sourced, and without having to sacrifice the feature functionality that you provided to your applications. So you want a multi-purpose, multi-model database to be powering this kind of capability, to keep that data architecture simple. And we expect that one of the first exercises our customers are going to be doing is simplifying that data architecture so that they can build these kind of applications. So complexity and latency, right? The two things I've been talking about all morning. High speed, highly reactive kinds of interactions, low latency, and reduced complexity. Those are the enemies of your AI-enabled adaptive application. So multi-model NoSQL systems, not only myself, but others, are going to help simplify those architectures. Now, number three is you're going to need that same kind of analytic capability I just mentioned in that Domino's example regarding the baseball teams. These AI applications need to have their analytic information co-located with their operational information, and in many cases also co-located with their AI and LLM interactions to reduce that latency and also provide that real-time metric that could be critical to deciding whether to make that pivot or not. You don't have enough drivers. Well, can you call DoorDash people in to drive for Domino's? Maybe. You don't have enough dough. Well, dough takes a day and a half to rise. So that might be a barrier to being able to pivot in real time to one market. So you want calculated analytics as an important ingredient to this AI enablement. And if you're getting that from your traditional lakehouse kinds of systems, the bummer is that turnaround time might not be real time enough. Reducing that latency gap is really important. And finally, the thing to remember is that the data that is feeding your LLMs for personalization's sake, guess where that originates? It's on your mobile devices. Your location information, your personalization of who it is, what kind of interactions are they doing, when did they last log on, all of that information starts at mobile. And in many, many cases, all the consumption of the results of that information ends on a mobile device. So if you don't have an embeddable mobile solution involved in this whole kind of architecture, you're going to be missing out on that one of those key capabilities for building these AI-enabled adaptive applications. And of course, it needs to be provided on a scalable, distributed, high-performance, multi-purpose, multi-model database platform so that it can go wherever it needs to go. So I talk about mobility a lot here, and I want to just remind everyone that there's a high likelihood that you have at least half a dozen applications that are sitting on your phone that are powered by Couchbase on the back end. So, and I've said that making the world easier for our developers is what Capella's goal is, and we're continuing to accelerate developer adoption here, from accessibility, from supporting an easy to create singular account, from allowing you to create and turn on and off your activities overnight so that you're not burning resources while you sleep, improving the overall developer experience. So recognizing that each developer has a different set of priorities, different skill sets of developers. There's the Java character versus the .NET character, and supporting the conversational coding to aid in developer productivity. Learn Couchbase very quickly and use a coding assistant like a Copilot in this regard. So ultimately, the other critical issue that we were describing is security. And what are the things that you're worrying about when you're looking at enterprise grade security in a database as a service or in any deployment? Is the environment hardened? You're considering infrastructure security. You're considering your overall network security, including VPC peering and private linking and things like that. You're worried about access controls and authentication controls. You're worrying about data encryption, whether it's in transit, field level encryption, backup level encryption, those kind of things. And are you monitoring for active threats in the environment and looking for those things? Those are all the different layers that are supported inside of Capella right now. And we've achieved a number of security compliances and our ongoing operational goals for data isolation, for protection, for access protection, for locking everything down, for keeping a very, very narrow surface area in the environment, intrusion detection, and of course SOC 2 Type 2 compliant, HIPAA compliant, PCI DSS compliant, C-Star Level 2 compliant. All of these are now supported in the Capella environment. So very, very appealing to organizations where security is an absolute must. All right, so I'm starting to wind down, and I'll field questions in Q&A and whatnot in a second. But reduce overall high cost of operation with Couchbase and with Capella. As you've noticed, all of those different feature data access patterns were things that other purpose-built databases do. There's one for being an in-memory key value store, one for being a document store, one for being a SQL store, one for being transactional, one for being search, one for being streaming, one for being large-scale analytics, right? All of those can ultimately be replaced or drawn down and eliminate more than half of the infrastructure, because most of those all are carrying 3 copies of the data, 3 instances or nodes of minimum of each one of those systems to serve a singular application. So what we find, and our customers, we've surveyed them, is that when we ask the customers, how much did you save when you converted to Couchbase? 53% of more than 300 customers asked said that they saved more than 50% in their overall TCO after switching to a Couchbase product. So you gain better performance, reduce data complexity, which allows your developers to build things faster in a singular architecture. It goes faster. It does more work than with less resource than what you're accustomed to. So you save money, save time, improve the quality of your system, and enjoy the benefits overall of somebody else managing your Couchbase environment. So versus competitive solutions, the way we look at things is legacy relational databases have flexibility problems. Schema and evolving schema is still an issue that slows down your application rollout cycles, and they get expensive. The purpose-built NoSQL systems are typically, they're in many cases one-hit wonders. They're a document store, they're a key value store, they're a search mechanism. They don't necessarily have performance at scale, as I showed you earlier. They don't have the ease of development, like using SQL++ as their as the query environment. And they're missing other key elements like mobility in many cases, or distributed transactions in many cases. And the cloud service providers, in many cases, if you're looking to avoid, adopting a singular CSP, that's a benefit that we can offer. We run across all three major clouds, and many of these systems are built using that purpose-built or point solution kinds of designs. So that's becoming a more and more obsolete design pattern, where you're using purpose-built databases for each thing. Multi-model, multi-purpose systems are beginning to take those things over. And I think you're going to see this looking ahead too, when all the database vendors start to add vector search to their capability list, right? That's going to be a feature and not a standalone database category. You're going to see reverse ETL products come on the market. And you know what? That's a feature. It's not a database or a system category, for providing that kind of capability. You're going to see metadata catalogs, all right, on the market. That's currently a database category or a vendor category. It's going to become a feature, right? We see this as part of the vision of what's going to end up happening in the market, and prove me wrong, I think is the way I will challenge anyone out there to at it. So last customer I want to talk about is FIBA Bank. Again, another one of these online, very, very rapidly growing banking services. They want to be a cloud bank. As I said, SoFi like cloud bank. They're just operating in the EMEA market and they're using Couchbase so that they can, for all of those low latency, high throughput kinds of requirements, the eventing service, for example, to stream information in and out. They're using us for user profile store, mobile application delivery, caching capabilities, and serving over 200 million logs and 20 million versus 20 million in their previous system. They're enjoying 5 nines availability and disaster recovery capabilities, and they're just getting started. So we focused quite a bit on the financial services orientation with this presentation. However, you'll find Couchbase everywhere, whether it's retail, travel and hospitality. Almost every airline ticket you've ever purchased ran through a Couchbase system. Shipping, technology and business services. Everything that you watch on television, you stream on television, whether it's your Peacock login, your DirecTV login, also executed through Couchbase. Gaming is very, very large with us, as is manufacturing and utilities. It is really a universal, creating user-centric applications that are creating degrees of personalization, are indeed a huge category of capability here. So what do we do next? I want to thank everyone for your attention here. Look for other Couchbase events. Get to know us. Look for things like a hands-on meetup, or set up a call with one of our technical advisors to go deeper into our architecture, go deeper into what we might be able to provide you. We do workshops, with a particular use case to prove out the viability of a Couchbase solution. You can sign up for a free independent trial with no hassle from us. You can begin with a Capella starter kit. These kits are available on the marketplaces from AWS, Microsoft, and Google, and just jump in directly and use all of the features of Couchbase in a very easy, consume as many, as few credits as you want while you're getting to know us. And again, for more information, we have some great content that we've created. How to modernize your applications is a paper we've produced. Why use NoSQL is another great one. We've got a ton of different video content for folks to play. There's the Capella trial. There's a playground for you to try out Couchbase, just interactions with the database live in a sandbox. So all of these are great ways to, again, get to know Couchbase a little bit more. So I thank everybody for your attention. Can I elaborate on the write back in columnar analytics and how Couchbase tackles the reverse ETL issue? Yes, I will do that. And I'm going to go back up to my slide that covers or talks a little bit about that. So what we're doing in terms of writing back to from the analytics, we execute a large-scale calculation. We've ingested the data. We're using Kafka as a major player in our data ingestion, data ingestion and in reverse ETL kinds of capabilities. But the primary one is that red arrow, right? Is when we can write back into the Couchbase key value store and have the Magma key value store for all of the operational services from the columnar analytic engine. So it talks to in memory in real time when it's got a new value that it's calculated. It can put that into a new field in a document, for example, or a new field in the underlying key value store. The change gets picked up in the operational services, and then you can write additional logic like when a user-defined function when this value changes, inventory changes for a particular region or something like that, then execute a new piece of functionality. So that particular write-back is built into columnar and its relationship with the operational services of Capella. And we will ultimately also see capabilities here in using Kafka in the reverse direction and pushing data into these third-party systems. There's, of course, we got to be sensitive to the formatting and the transformation requirements that are needed to do that, so we don't break somebody else's system. But those kind of things are, as I mentioned, we're sensitive to that, and we'll end up providing utilities for that kind of thing as well. Any other questions or things in the chat? I want to see what I've got here.
I don't think we have any more questions, but I just want to give a shout out to the docs section. Before you turn off the webinar here, check out the docs section. We do have a link to Jeff's presentation here. I know he has some follow-up information on the last couple slides. And then we also have, some of our customer use cases if you want to dig deeper into FICO, Equifax, PayPal. There's the customer use cases there. You can dive a little bit deeper, or any of our customers. And if you have questions, I know Jeff's on LinkedIn. You can look me up. I'm happy to push you in the right direction. And otherwise, I hope you all have a wonderful new year planned, and we will see you back in January. So
yes,
everybody
Happy
take
holidays.
care. Thank you so much, Jeff.
All right, cheers. Thanks so much, everyone.